Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the surprisingly complex world of decoupling capacitors. Specifically, why the ubiquitous 100 nanofarads is, frankly, outdated.
Ooh, sounds juicy. I've always just thrown 100 nanofarads caps on my boards without much thought. What's the fundamental problem with this approach?
The core issue lies in understanding the dynamic current demands of modern digital circuits. It's not just about the clock frequency, it's the incredibly fast rise and fall times of those signals. Think of it like this: a steep cliff versus a gentle slope. The steeper the edge, the higher the frequency components involved.
I see. So faster rise times mean higher frequencies? And that's where the trouble starts?
Exactly. These high-frequency currents encounter parasitic inductance in the PCB traces. Essentially, the wires themselves act like tiny inductors. This inductance creates voltage noise, degrading signal integrity, and potentially causing glitches or EMI.
Right, so the inductance creates a voltage drop proportional to the rate of change of current, di/dt. And that's where the decoupling capacitor comes in, acting as a low-impedance path for these high-frequency currents, right?
Precisely. The capacitor shunts the high-frequency noise to ground, preventing it from affecting the power rails. But here's the kicker. A 100 nanofarads capacitor, while seemingly sufficient in older designs, simply doesn't cut it with today's high-speed components. It's short. Its impedance is too high at the relevant frequencies.
So bigger is better. A 1UF capacitor would have lower impedance?
Yes, but it's not just about the capacitance value. Real-world capacitors have parasitic inductance and resistance, ESL and ESR. This creates a self-resonant frequency, SRF. Below the SRF, the capacitor's impedance decreases with frequency. Above the SRF, the parasitic inductance dominates, and impedance increases. A larger capacitor, especially in a smaller package, will have a higher SRF, extending its effective range.
I'm following, but it's a lot to take in. So why the 100 nanofarads obsession then? It's not just bad practice, is it?
It's a legacy issue. In the 80s, capacitor technology was less advanced. 100 nanofarads was a good compromise between cost, availability, and performance. The big little approach, 100 NF plus 1 UF, was a workaround for the limitations of the time. But now, high capacitance, low ESL capacitors are cheap and readily available.
So we should just ditch the 100 nanofarads and go straight for something like 1 UF or even larger, in the smallest package possible, right next to the IC?
Generally, yes. The cost difference is negligible, and the improvement in performance is significant. Just be mindful of inrush current if you're using many large capacitors on a single rail, and avoid placing them too close to sensitive control loops.
Got it. This has been a real eye-opener. Thanks for clearing up this long-standing mystery.
My pleasure. Remember, proper decoupling is crucial for stable and reliable circuits. And don't be afraid to leave those 100 nanofarads relics behind. Thanks for listening to Tech Bytes and News. Have a great day, and we'll catch you next time.
Bye-bye.